previous session, we have seen how to construct a maximizer module using structural description, which is as shown. Here, the structure of 2:1 4-bit multiplexer was preserved. In this session, we'll be seeing the behavioral way of describing the same maximizer module. For that, we'll be adding a new Verilog module in the same project. And we'll set it as top module. Now in the module, we'll add the terminals, which are A, B, C, D, and Q, each as 4-bit array. And same with the output, Q. Now in the behavioral model, we'll be describing the behavior of the module in exact. So since we'll be using always block for sorting or for checking the maximum of the numbers among these four, first we'll be comparing A, B, then C, D, and max of both sets will be taken up in some temporary variables. So we'll be creating some temporary registers as temp1 and temp2, and each of 4-bit, which will be storing the temporary maximums amongst the two numbers in the set. So let's use always block and with sensitivity parameters as all the inputs. So we use star or asterisk marks to show that. And then we'll be wrapping the statements in begin and end. So inside, our strategy will be to fetch the temporary maximum amongst two numbers. So here, if A is greater than B, we want temp1 as A, else temp1 as B. So it's very compact and easy to describe the behavior. And similar statements will describe for CD as well. So instead of A, we'll be mentioning C, and instead of B, we'll be having D. And the other temporary variable will be used to store the maximum in C and D. And then the concluding if-else block for checking the maximum amongst the temporary registers. And here we'll be setting the output using blocking statement. So here the behavior is described using conditional logic. So let's quickly synthesize and check the register transfer logic schematic, which will be more or less similar. So we have some warning message, which is not that important right now. So the top level schematic, it looks more or less same. Let's venture through inside, or let's look at the internal block. So it is more or less similar to what we had in structural description. Yeah, 3 comparators and sets for each bit. So having done that, let's test the module. So we'll be using a test fixture. Since the system is same, like the structural system and the behavioral system, we'll be duplicating or we'll be copying the initialization part from the text fixture. So let's check the syntax and simulate the model. And let's change the radix to unsigned decimal. And let's change the color again for the output. And here we can again see the functionality gets tested.